With the development of the digital economy, firms are awash in data, but they're finding it surprisingly difficult to get the benefits from it that they expect, especially when it comes to management decision making. In this screencast, I'm going to describe how system simulation, in combination with a decision-making framework, puts data to use as a strategic management tool. To understand why having lots of data is not the panacea that it's hyped to be, consider this value progression. The most fundamental value proposition is to comprehensively collect event or transaction data in a consistent way over time so that it can be used. Obviously, the volume and velocity of this data stream is growing exponentially. The current excitement about big data is mostly generated by powerful data science tools that allow organizations to blend data from multiple sources, find and visualize patterns, and sometimes predict those patterns into the future. These patterns are discovered through correlational style modeling. The value proposition here is mostly in helping managers create situational awareness, increasing their understanding of the current situation and the near future. This in turn supports tactical decision-making and tactical actions. A good example of how this works is credit card fraud detection. By observing transaction patterns, firms can effectively predict that a specific credit card is being used or is about to be used fraudulently, and the card can be canceled. Big data and data science tools can do a good job describing the past, present, and some things about the near future. But the essence of management is knowing what actions to take today to create a future that's different from the past. This requirement leads to decision technology based on system simulation. System models describe the structure that creates the data patterns. System models are a cause and effect hypothesis of how today's actions will lead to future results, sometimes far into the future. Since management decision-making is about the future, there are always going to be important factors in those decisions that our big data tells us little about. For that reason, we need to combine our system simulation with a decision framework that deals effectively with uncertainty. I call the combination of system simulation and the decision framework decision technology. Modeling and data collection, when done correctly, work in a reinforcing relationship where good data improves the models and good models improve the data. A good structural hypothesis, in the form of a system model, directs managers towards the patterns and events that are significant and helps them identify and discard spurious correlations. In the context of decision technology, rich historical data is used primarily to determine what the structure of the system is that creates the behavior, rather than directly predicting the future. System structure is captured in the simulation. Then the simulation is used to create a range of what-if scenarios to guide decision-making. The impact of uncertainties about the future are presented to stakeholders in a way that allows them to minimize their decision regret, leading to the best choice. The idea of decision regret in this situation is completely parallel to how regret works in our everyday lives. It is the difference between the results we actually got and what we would have gotten had we been able to predict the future with perfect accuracy and make the perfect choice. Using regret is a great way to guide decision-making when there are factors about the future that are simply unpredictable. In management decision-making, there are always important, uncertain factors. The regret calculation is made possible by the system simulation results. Because this approach generates detailed expectations about the impact of management decisions, it's possible to rationalize expectations against actual outcomes. This process creates a cycle of deep learning about the data we are collecting, how we're reporting and using it, and the correctness of our system model. My first example of decision technology is our inventory policy tool, Goji. There are detailed screencasts and materials on the Decisio Tech website describing Goji. Briefly though, Goji is a tool that allows managers to make good inventory and line loading decisions in the face of significant demand uncertainty. The underlying system model captures both the physics of the firm's supply network as well as market behavior and feedback. The simulation produces a set of scenarios describing future cash and material flows. Results expectations are then visualized so the decision stakeholders can choose the alternative with the least decision regret. Next, here's an example concept application of decision technology to a media planning case. In this case, managers have to choose between alternative marketing resource allocations. The system simulation includes a detailed causal model of purchase funnel dynamics and how those funnel dynamics interact with the rest of the business system. The broader business system may include competitive response, firm economics, macroeconomic conditions, or other things. There may be significant uncertainties about the future state of the business, including competitor intentions and capabilities, consumer response, and other factors, and these are captured as part of the input scenarios. The tool works by creating a set of results expectations based on a scenario for every possible input case. These results expectations are then visualized for stakeholders in a way that allows them to minimize decision regret and choose the best resource allocation. As a final concept example, consider the application of data science and decision technology to a household insurance case. The blending of multiple sources of data to support the creation of a good model of household dynamics is important. The household dynamics model generates both claims expectations and policy purchase behavior. These interact with the market for coverage, creating a set of result scenarios. Managers would choose product offerings that minimize decision regret. This wraps up my introduction to how data collection, data science, and system models can work together to support management policy and decision making. Thanks for watching this screencast.